Here is the continuation of our series on logarithmic differentiation. Find the second derivative of y is equals to root x ln x. Now, this question can be written as y is equals to x raised to the power of 1 over 2 natural log of x. Okay, now from our previous class, if I ask you what rule are you going to employ to differentiate a function that has two parts and these two parts are multiplying each other? Yeah, you are going to employ product rule of differentiation. Okay, don't forget that from our previous class, if we have a function like this, uv, derivative of y is what? Derivative of u multiplied by v plus derivative of v multiplied by u. You understand? So, if you compare this with this, you can set u is equals to x raised to the power of 1 over 2 and v is equals to what? Natural log of x. You understand? Okay, let's proceed. Differentiate u. Derivative of u is equals to what? 1 over 2. Don't forget, using the power rule, we are going to multiply the power by the coefficient of x, which is 1, and the power will reduce by what? 1. So I'm going to have 1 over 2x minus 1 over 2. Do you understand? Okay, let's take the derivative of v. Derivative of v is, if you differentiate ln x, you're going to get what? 1 over x. Because from our previous class, if we have a function that looks like this, y equals to ln x, the derivative of y is what? You are going to differentiate. First, you are going to take the function inverse of the function inside the bracket. So I'm going to have 1 over x multiplied by the derivative of x. Derivative of x is what? 1. So I'm going to have derivative of y is equals to 1 over x. So let us proceed. Now, we have taken the derivative of u and v. We can make use of this formula now. So let's take the first derivative of y is equals to derivative of u. Derivative of u is what? 1 over 2 x raised to the power of minus 1 over 2 multiplied by v. V is what? V is ln x multiplied by ln x plus, open another bracket, derivative of v. Derivative of v is 1 over x. So I'm going to have 1 over x multiplied by u. U is what? X raised to the power of 1 over 2. X raised to the power of 1 over 2. Let us proceed. The derivative of y is equals to 1 over 2 all into bracket x raised to the power of 1 minus 1 over 2. This is multiplication sign. Multiplied by ln x plus 1 over x can be written as x raised to the power of minus 1. So I'm going to have x raised to the power of minus 1 multiplied by x raised to the power of 1 over 2. So the derivative of y is equals to ln x into bracket 1 over 2 multiplied by x raised to the power of minus 1 over 2 plus, according to the law of indices, if we have x raised to the power of a multiplied by x raised to the power of b, this will give x raised to the power of a plus b. You understand? So we are going to apply the same rule here. So since we have the same base, we have x and we have x. So I'm going to have x raised to the power of minus 1 plus 1 over 2. You understand? So that will give us x raised to the power of minus 1 over 2. Do you understand? X raised to the power of minus 1 over 2. You understand? So the first derivative of y is what? Ln x into bracket 1 over 2 x raised to the power of minus 1 over 2 plus all into bracket x raised to the power of minus 1 over 2. So the first derivative of y is this. Now the first derivative of root x ln x is this. Now let us take the second derivative. You can see, to take the second derivative, I have to use the product rule to differentiate this part. Then I'm going to find the derivative of this part. Are you getting it? Because I have two parts that is multiplying each other. So I'm going to employ product rule to differentiate what? This part. Now let us proceed. The second derivative of y is equals to, don't forget, according to product rule, this is what? U. And this is what? V. Okay, let's find the derivative. I'm going to first differentiate U. So differentiate lane x. I'm going to have 1 over x multiplied by v. V is what? 1 over 2 x raised to the power of minus 1 over 2. Okay, please, I want you to pay attention. Plus, so I'm going to have my plus here. V is what? I'm going to take the derivative of v now. Are you getting it? So the derivative of v is minus 1 over 2 will multiply 1 over 2. So I'm going to have minus 1 over 4. Then minus 1 over 2 will reduce by what? Minus 1. Are you getting it? That is, I'm going to have minus 1 over 2 minus 1. This will give me minus 3 over 2. So for this, I'm going to have multiplied by x raised to the power of minus 3 all over 2. So I'm going to multiply the derivative of v by u. Don't forget that u is what? Lane x. So I'm going to have another bracket here, multiplied by lane x. So I have taken the derivative of this part. Are you getting it? So it remains the derivative of x raised to the power of minus 1 over 2. So let's proceed. So I'm going to have another plus here. Don't forget, this is an entity. You understand? This is the derivative of this part. So let's take the derivative of x raised to the power of minus 1 all over 2. So I'm going to have, using the power rule, I'm going to have minus 1 over 2 x raised to the power of minus 1 over 2 minus 1. That is also minus 3 all over 2. You understand? So let us proceed. Let us simplify. So the derivative of y is equals to lane x all into bracket minus 1 over 4 x raised to the power of minus 3 over 2 plus 1 over x all into bracket 1 over 2 x raised to the power of minus 1 over 2 plus minus 1 over 2 x raised to the power of minus 3 over 2. Do you understand? I only bring this to this part and I bring this to this part, then I will write this. Okay, let's proceed. So the second derivative of y is equals to lane x multiplied by minus 1 all over 4, put this in bracket. Don't forget that x raised to the power of minus 3 over 2 can be written as 1 over root of x raised to the power of 3. So for this, I'm going to have 1 all over multiplied by 1 all over root of x raised to the power of 3 plus 1 over x all into bracket 1 over 2, and also x raised to the power of minus 1 over 2 is also the same thing as 1 over root of x. You understand? So I'm going to have 1 over 2 multiplied by 1 over root of x plus minus, because I'm having minus 1 here, so my plus multiplied by minus, that will be minus. So I'm going to have minus 1 all over 2 multiplied by 1 over the root of x raised to the power of 3. Do you understand? According to the law of indices, if you have x raised to the power of minus 1, it's also the same as 1 over x. So 1 over x raised to the power of minus 1 over 2. Oh, sorry. 1 over x raised to the power of 1 over 2 is also the same thing as what? X raised to the power of minus 1 over 2. So that's the law that I apply here. So let's proceed. The second derivative of y is what? The natural log of x multiplied by minus 1 over 4 root of x raised to the power of 3 plus 1 over x all into bracket 1 over 2 root x minus 1 all over 2 root x raised to the power of 3. Do you understand? So let us proceed. the second derivative of y is equals to ln x into bracket minus 1 over 4 root of x raised to the power of 3 plus 1 over, if you open this bracket, you are going to get 2 root x multiplied by x. You can just leave it like this, but you can, for me, I can just open the bracket. So I'm going to have minus 1 all over 2 root of x raised to the power of 3. So simplify further. So the derivative of y is equals to, so open this bracket with this ln x. So I'm going to have minus ln x all over the 4th root of x raised to the power of 3 plus 1 over 2x root x minus 1 all over 2 root x raised to the power of 3. So the second derivative of y is equals to root x multiplied by ln x is this. Thank you very much.